Welcome to Lesson 8.5. We're dividing powers with the same base and then also raising a quotient to a power. Let's look at the key concepts. When dividing powers with the same base, if you have a to the m divided by a to the n, we can subtract the exponents, so the a to the m minus n, and we get the result. If you look at the example, 3 to the 7th divided by 3 to the 3rd equals 3 to the 7 minus 3, which is 3 to the 4th. Imagine that we have 3 times 3 times 3 times 3 times 3 times 3 times 3. And we're dividing that by 3 times 3 times 3. We can start to cancel out, one for every numerator and one for every denominator, and we can see the result. Right? If you have a fraction, okay, if you have a quotient, fraction, and you're taking that to the power, you can distribute the power to both pieces, and it works just the same. Let's look at our first example here. We have p to the 3rd times j to the negative 4 over p to the negative 3rd j to the 6th. So our rule tells us that we can take and p to the 3 minus a negative, okay, gotta watch that, times j to the negative 4 minus 6. So we're following our rules for dividing powers with the same base, and we're left with p to the 6th, j to the negative 10th, and then you could rewrite that, p to the 6th over j to the 10th to get rid of the negative. All right, that's one way to solve it using our division rules. Now, we didn't clear this expression of negative numbers, did we? So if we would, it would avoid some of the possible errors or potential errors for like minusing a negative. If you follow the rule, just be careful with your signs. You could do this a couple of different steps here. Let's try this again. We could do this problem a different way by clearing the expression of negatives first. And we could rewrite that as p to the 3rd times, and then this p to the negative 3rd, remember we use its ticket, and it comes up and we get p to the positive 3rd, okay? We've got j to the negative 4, so that's going to use its ticket to come down into the denominator and become j to the 4th, and then we have j to the 6th. This is just a second way to do this problem to show you that all of your rules are connected. And so now remember, if we have p to the 3rd times p to the 3rd, that becomes p to the 6th, and then divided by j to the 4th times j to the 6th. If we add those exponents, we get j to the 10th. So it's very important to keep track of your rules and ask yourself what is really happening. As long as you follow your instincts, you're going to do fine with these. All right, let's look at the next example here. If I can find my cursor. Maybe, maybe not. Here we go. So we have a small dog's heart beats about 64 million beats a year. If there are 530,000 minutes in a year, find the dog's average heart rate in beats per minute. So the first thing I did was I wrote 64 million beats. Okay, this is beats here. Oh, I got a green pen. That's beats, and this is the number of minutes. So if we take beats and divide it by minutes, we should get the beats per minute. So I took 64 million and made that 64 times 10 to the 6th. 10 to the 6th is a million, right? And then 530,000, 1,000 is 10 to the 3rd. Therefore, we have 530 times 1,000. So now what we can do is we can use our rule here. We can take the 64 and divide it by 530 with our calculator, where that math isn't going to change. And we get about 0.12. Okay, so we get 6.12. And then if we take 10 to the 6th divided by 10 to the 3rd, using our rule over here, we can subtract and we get 10 to the 6 minus 3, which is also 10 to the 3rd. So we're left with 0.12 times 10 to the 3rd. Now, we should probably write this in proper scientific notation, so we want the decimal between the 1 and the 2. So we have 1.2, and since we moved it to the right, we're going to take 1 away, and that gives us 10 to the 2. The other thing is, this is just about, think about what 10 to the 2 is. That's 100, right? So it's about 120 beats per minute. Okay, does that make sense? That sounds about right. Moving on to our next example, we have raising a quotient to a power. So here we have, here we have 3 to the 1st divided by y to the 3rd, and that whole quotient is taken to the 4th power. I put the little 1 there for you to kind of remind you, and we can take 3 to the 4th and divide it by y to the 3rd times 4. So we get 3 to the 4th over y to the 12th, 3 to the 4th, 81 over y to the 12th. It's really important to keep your work neat for these. All right, go ahead and try the next few quick checks. Pause. When you're ready, check your work. If you have any questions, write them down, send me an email, or have them ready for class. So if we are simplifying b to the 4th over b to the 9th, using our rule, we would subtract and we get b to the -5, and then we want to leave it in without a negative for exponent, so we have 1 over b to the 5th. Here we have, we end up with negative exponents as well. We end up with a to the -2 times b to the -2, which means we can bring them both down to the denominator, and we have 1 over a squared b squared. Again, there are multiple ways to do these problems, so you want to be efficient and make sure you're writing down your work and justifying your answer. If it doesn't make sense, if you're looking at this, if you need to, for something like b, think about a times b in the numerator over, we have 4 a's in the denominator, right? A, and 3 b's, b, b, b. Now remember, just like with reducing, 1 in the numerator, 1 in the denominator will cancel out, okay? We can cancel out a b here, and so what's left in the numerator is understood to be 1, and then we have 2 a's and 2 b's, which represent a squared and b squared. All right, C, notice this -1 power here. So that actually, -1 minus 3 gives me a -4, and that will have to be brought down to the denominator. And then we have n squared to the n. If we subtract, that gives us n to the 1, or just n. And again, be careful, be systematic with these. We get x to the 1st, z to the 7th, over y to the 5th. And you could do this a couple of different ways. You could take care of all of your negative signs first, having everything a little bit happy, using all of its tickets, and then follow whichever rule. If they're one's in the numerator and one's in the denominator, we can subtract. If they're both in the numerator, we can add the exponents. Again, there's several different paths to take with these, but the most important thing is that you get the final solution. All right, so we are finding, we're using scientific notation here for the next problem, and we are dividing. We have 2 times 10 to the 3rd over 8 times 10 to the 8th. So we can divide, or we can subtract. We take 2 divided by 8, we get 1/4, right? 1/4 is the decimal, 0.25. 10 to the 3rd divided by 10 to the 8th gives us a result of 10 to the -5th. So then to write it in proper scientific notation, we have 2.5 times 10 to the -6th. Over here, again, if we are dividing, we can divide 0.75 by 2.5. We get 3. 10 to the 12th minus a -4 gives us +4. which gives us 10 to the 16th. Word problem. The total population of the United States recycles 2.7 million tons of glass each year, or in 2000, the population in 2000 was approximately 281.4 million. On average, how many tons of glass were recycled per person? So the first thing we do is we have 2.75 times 10 to the 6 tons. We know our population was 281.4 times 10 to the 6th people. So if we divide and follow our rules here, we end up, and you can use your calculator for this too, 9.59 times 10 to the negative third pounds, or tons, excuse me, tons per person, okay? If you would, when you have a moment, try the quick check and we will move on. I'm sorry, that was a quick check. We're simplifying the exponents here. So we have 2 thirds to the negative 3. We can rewrite that as 2 to the negative third over 3 to the negative third. Because both of these have negative tickets, we're going to flip them. 3 to the third over 2 to the third, and then in this case we have 27 over 8, and I would just leave that since it can't be reduced at all. In this case there is a negative sign here, and I have that circled. It's probably not circled in your notebook, but you want to circle it because that's an extra long, and as I've taught you in the past, I would prefer you put that in the numerator. Either way, we're going to take everything in here to the negative 2 power, so that gives me negative 4b to the negative 2 power, okay, negative 2, over c to the negative 2. So c to the negative 2 comes up and becomes c squared. Here we now have negative 4 to the 2nd power, okay, I've used its ticket to come down, and then b to the 2nd power. So as we start to reduce this, I have a little bit of leftover stuff here. As we start to reduce these, we can see we have c squared. Negative 4 times negative 4 is 16, and then b squared. Go ahead and try the quick checks. When you're ready, start the video back up and check your work. Here we have 64/27ths. Distributing the negative 3 and then flipping them over. It's important to understand here that when you have the negative in the fraction, put it in the numerator. So we have negative 1 to the negative 5th power, which is just going to be negative 1 in the denominator. And then 2 to the negative 5th power actually comes up to become 2 to the 5th power, which is 32 divided by negative 1, which results in negative 32. Here we have to the negative 1st power, so we would 2 to the negative 1st power times r to the negative 1st power divided by s to the negative 1st power. So everybody's going to use their tickets to go opposite places, and we're left with s over 2r. In this case, we're distributing the negative 2, so we would have 7 to the negative 2 times a to the negative 2 divided by m to the negative 2. So again, we're going to use those tickets up as fast as we can, and the m comes up to become m squared, and the 7 to the negative 2 comes down to become 7 squared, which is 49, as well as the a squared. Again, please, if you have any questions, don't hesitate to ask.